Welcome friends. Uh, Today we discuss about the energy conservation opportunities or energy conservation measures in boilers. The purpose of the performance test in boiler is to find out the efficiency of the boiler and to find out the evaporation ratio of the boiler. The boiler efficiency means the ratio between the heat in steam output divided by heat in fuel input, which means the amount of heat is utilized to produce the steam. The input heat is from coal and output heat is to supply the steam. Okay. Then the second parameter is evaporation ratio, which means the uh, amount of steam generated per fuel per kg of or per ton of fuel consumption, which is the two main parameters which is used to assess the performance of the boiler. Okay. Then basically boiler efficiency can be tested by the two methods. One is direct method, which is nothing but the energy gain of the working fluid is compared with the energy content of the boiler fuel. Then the second method is the indirect method. Here the efficiency is calculated from the various losses and the energy input. Okay, let me discuss one by one. First one is the direct method. In the direct method, see the schematic diagram. The boiler input is water and the boiler fuel input is fuel and air, which are the inputs, and the outputs are the flue gas is like combustion gases, and the output is another output is steam from the boiler. Okay, therefore the fuel input and flue gas output, then water feed water input and steam output, which is the main input and outputs of the boiler. Okay, from that efficiency equal to heat addition to steam divided by gross heat in the fuel. Okay, then the particular formula is the steam flow rate into steam enthalpy is output of the boiler and feed water enthalpy, which is input of the boiler, divided by fuel supply, fuel firing rate. Fuel may be coal or furnace oil, etc., or low sulfur fuel oil. Like that, the various fuels are not, and also naphtha. These are the fuels and calorific value. Okay, now the fuel firing rate and the gross calorific value, which is the formula for direct method of boiler efficiency. Okay. Then now we discuss about the direct method is very simple method, but it shows only what are the inputs, the comparison between input and output. Okay, very easily we can assess the boiler performance with the direct method. In the indirect method, we have calculated various losses. See the diagram. The fuel input and the air, fuel plus air is supplied to the boiler and water is supplied to the boiler and steam is outputted from the boiler. It's the same in indirect method. Then the difference is we separate or we classify or separate the each and every losses. Okay, first one is dry flue gas loss, second one H2 loss, loss due to dry flue gas, loss due to hydrogen in fuel, loss due to moisture in fuel, loss due to moisture in air, and loss due to carbon monoxide, and loss due to surface radiation, convection, and other unaccounted losses. That unaccounted losses which is very small and which is difficult to measure. Okay, which is the applicable for liquid, gas, and solid fired boilers, and two more losses are particularly for solid fuel boiler, because solid fuel only having ashes. Liquid and gaseous fuels are compared to the solid fuel, the ash content is very less. Okay, then the remaining losses are particularly for solid fuel fired boiler is unburned losses in fly ash, unburned losses in bottom ash. The high density ash is separated in the bottom, and low density ashes are escape with the flue gases. Okay, which is called fly ash, and that one called is bottom ash. Okay, both are having carbon. Let me discuss one by one. Then the boiler efficiency is 100 minus summation of all the losses. Okay, then efficiency procedure. First we find out the theoretical air for combustion. First we find out the theoretical air for combustion for a particular figure. The is 11.6 into carbon plus 34.6 into H2 and O2. The carbon H and H2 and O2 are percentage of carbon and percentage of hydrogen and percentage of oxygen available in the fuel. These contents are determined with the help of ultimate analysis. Okay, refer that ultimate analysis in chemistry subjects. Okay, then H2O2 and 4.35 into S divided by 100, that is unit is kilogram of fuel. Okay, then excess air, because we cannot pass it is impossible to send the exact air required for the combustion. Therefore we have I have some additional air that we have supplied some additional air, which is called the excess air. That excess air percentage is calculated by the either percentage of O2 available in the flue gas or either CO available in the flue gas. Okay, for both the cases we can calculate the excess air supply. Okay, the formula is O2 minus 21 minus O2 into 100. Okay, for O2 O2 measurement of O2 is recommended. Okay, if we cannot possible to measure the O2, then use the another formula which is related to CO2 measurement. The formula is 7900, little bit difficult. 7900 CO2% theoretical and CO2% actual, and CO2% divided by CO2% actual into 100 minus CO2% actual. From this CO2% theoretical is calculated by the formulas, and the CO2% actual is measured in the flue gas. Okay, then this is the procedure to find out the CO2% in theoretical. Okay, then CO2% theoretical, CO2% actual, and CO2% theoretical equal to moles of carbon available in the fuel and moles of N2 and moles of carbon. Okay, then moles of N2 is weight of N2 in theoretical air divided by molecular weight of N2, and weight of N2 in fuel divided by molecular weight of N2, which is the basic formula. Then the weight of molecular weight of the N2 is nearly equal to 28, and the weight of N2 in theoretical air is calculated by the proximate analysis, and weight of N2 is calculated by the ultimate analysis. Okay, then the moles of carbon equal to weight of C in fuel divided by molecular weight of C. Then by calculating the moles of N2 and moles of C and substituting this value into CO2 theoretical, then we can calculate the CO2 theoretical. Then substitute that CO2 theoretical in percentage of excess air calculated, and finally we get the excess air percent from CO2 measurement. Okay, this is the basic step, primary step for calculation of boiler efficiency in indirect method. Okay, then actual mass, then total air supplied. The first one is theoretical air supplied, and the second one is amount of excess air supplied, which is in the form of percentage. Then finally we can calculate the exact amount of exact supply of air, which is calculated from the formula, which is 1 plus EA. EA means excess air into 100 into theoretical air. Okay, from this formula we can calculate the actual mass of air supply. Okay, then from this important note 2, we have two notes. One is note 1. For quick and simple calculation of boiler efficiency, use the following. simple method can be used for determining the flue gas loss as given below. One is the total mass of flue gas per kg of fuel equal to mass of actual air supplied per kg of fuel plus 1 kg of fuel. Okay, this is the basic simple formula to find out the boiler efficiency. Then second note is water vapor is produced from hydrogen in fuel, moisture present in the fuel and air during the combustion. The losses due to these components have not been included in the dry flue gas loss since they have separately calculated as a wet flue gas loss, which is calculated by the formula. This mass of dry flue gas equal to mass of CO2 plus mass of N2 contained in the fuel and mass of N2 in the combustion air supplied plus mass of oxygen in the flue gas. Which formula is slightly difficult when compared to above formula, but we can determine the exact value of boiler efficiency through that formula only. Okay, the above formula is slightly simple, and we can get the efficiency through this formula also, but slightly difference is there between note 1 and note 2. Okay, then first loss, heat loss due to dry flue gases. This is the greatest boiler loss and can be calculated with the following formula, because a chimney having greatest energy loss because the fuel is firing and the heat is parts, a certain amount of heat is absorbed by this water and converted to the steam, then remaining exhaust gas is passed to the atmosphere through chimney, therefore which have the very high amount of potential heat, and we cannot use that potential heat. Okay, then the formula is L1 last one equal to mass of dry flue gases into Cp of dry flue gas is measured by the uh, measured in the flue gas analysis and flue gas temperature and ambient temperature and gross calorific value of the fuel. Okay, this is the first loss. Unit conversions are very important. Okay, here I take the specific heat as kilocalories per kg degree Celsius. Okay, and temperature is in degree Celsius, and mass is in kilogram of fuel. Okay, then second loss is heat loss due to evaporation of water formed due to H2 in the fuel. Every fuel having hydrogen. The total fuel have the fuel having carbon, hydrogen, sulfur and oxygen. Therefore, the hydrogen present in the fuel is during combustion is converted into H2O. That H2O is escaped from the boiler through chimney gases. Therefore, which is also another loss. The formula to calculate the that loss is equal to 9 into H2 into 584 plus TCP into TF minus TA divided by gross calorific value of fuel. In that heat loss, the major heat is transferred, loosed through latent heating. Okay, then 584 is latent heat of evaporation of water vapor. This is equal to kilocalories per kg Kelvin. Sorry, kg. Then next loss is heat loss due to moisture is present. For example, in a storage unit, the coal is stored in a particular manner. Therefore, we can during the rainy time or in for some application we add a moisture. Therefore, the moisture content also present in the fuel. The moisture loss is made up of sensible heat to bring the moisture to boiling point, the latent heat of evaporation of the moisture, and superheat required to bring the steam to temperature of the exhaust gas. This loss can be calculated with the following formula. Is L3 equal to M into 584 plus CPT, and Cp is specific heat of superheated vapor and M stands for amount of percentage of moisture available in the fuel per kg basis, and TF is a flue gas temperature and TA is ambient temperature. GCV is nothing but gross calorific value of the fuel. Okay. Next loss is loss due to moisture present in air. Everybody knows the psychrometric concept, which means the air having certain amount of moisture. Everybody knows. Okay, that air is applied to the boiler. That moisture is converted to steam or absorb the some heat. So the moisture available in the steam state, but that moisture absorb some heat from the boiler and escape to the atmosphere. Okay, therefore we can calculate the loss of heat loss due to moisture present in air. Okay, for that we can calculate the specific humidity or latent humidity for the particular air. Okay, with the help of specific humidity, we can calculate the loss due to moisture present in the air. The formula is L4 is equal to actual air supplied into humidity factor. It's nothing but specific humidity is taken from the psychrometric chart for particular ambient conditions, and specific heat of superheated vapor and temperature difference of flue gas and ambient temperature and gross calorific. Okay. Then next loss is heat loss due to incomplete combustion, which is the main problem. The incomplete combustion, the complete combustion means carbon react with O2 and produce CO2, which is the complete combustion. But in some situation, there is an incomplete combustion occurs, which means the carbon and oxygen reacts and produce CO, carbon monoxide, which is it is called as incomplete combustion. Okay, the loss is measured based on the amount of CO emission present in the flue gas. Okay, that L5 equal to percentage of CO into C, percentage of CO available in the flue gas, and C carbon content present in the fuel, and the percentage of CO2 available in the flue gas, and 5744 is a multiplication factor, and GCV of fuel into 100, which is the another loss. It's called incomplete combustion loss. Okay, then next loss, heat loss due to radiation and convection effect. In the boiler, the temperature nearly 1000 degrees Celsius. Therefore, the high potential to occurring the radiation and convection losses from the lateral surface of the boilers. Okay, which is not a easy one to measure. This loss is not a easy way to measure. Okay, which is difficult to measure. Therefore, we can directly take the losses as a percentage for a various type of boilers. For industrial fire tube or packaged boiler, the loss is having 1.5 to 2.5%. Then for industrial water tube boilers, the loss is 2 to 3%. And for power station, which means large capacity boilers, the radiation loss is very minimum, which is equal to 0.4 to 1%. If the capacity of the boiler is lower, the loss is higher. If the capacity is gradually increases, which means the loss continuously decreases. Okay, or otherwise we can calculate the following formula. Through that formula also we can calculate the radiation loss. But the formula itself difficult. Which is L6 is 0.548 into TS minus 55.55 power 4 minus TA into 55.55 power 4 plus 1.957 into TS minus TA power 1.25 into square root of 196.85 Vm plus 68.9 divided by 68.9. Here L6 radiation loss and Vm wind velocity and T surface temperature and T ambient temperature. Surface temperature are the boiler wall. Okay, that formula is slightly difficult. You can refer the heat transfer book and you can see the derivation of that losses. Okay, now with here this which is not scope of our topic. We know only about the formulas. And heat loss due to unburned carbon. This is applicable only for solid fuel, boilers, a small amount of carbon will be left in the ash, and this constitute a loss of potential heat in fuel. To assess these heat losses, sample of ash must be analyzed for carbon content. The quantity of ash produced per unit of fuel must also be known. First one is heat loss due to unburned fly ash, the low density ashes, L7. Total ash collected per kg of fuel burn is measured by the flue gas analysis into cross calorific value of fly ash, because the fly ash itself having carbon. Then cross calorific value fuel. Okay, then second loss for that case, in the case is heat loss due to unburned in bottom ash is high density ashes. Okay, the total similarly the total ash collected per kg of fuel and cross calorific value of bottom ash divided by cross calorific of fuel. These are the losses in the solid, liquid, gaseous fuels. Okay, for solid liquid, these two losses are negligible, and for liquid and gas fired boilers, these two losses are negligible, and therefore we can vanish that losses. And for solid fuel boilers alone, that losses is significant, losses having a significant value. Okay, then finally heat balance. Having the established magnitude of all losses mentioned above, a simple heat balance would give the efficiency of the boiler. The efficiency is the difference between the energy input to the boiler and heat losses calculated. The heat balance sheet is like this. The sheet having the various input and output parameters. The input is heat input through fuel like coal and like that fuels, similar fuels. Okay, then various outputs are dry flue. So various losses are dry flue gas loss due to hydrogen in fuel, loss due to moisture in fuel, loss due to moisture in air, and partial combustion of C to CO, and surface heat loss, and loss due to unburned in fly ash, and loss due to unburned in bottom ash. Then we can calculate the total losses in the percentage to 100. Then the boiler efficiency equal to 100 minus all losses, which is the method to find, which is called as indirect method of boiler efficiency determination. Okay, in next session we discuss about one tutorial problem related to boiler efficiency.